Welcoming you all to the channel. And in the previous video we talked about finite series, and in this video what are we going to talk about? We're going to talk about elliptic curves. Okay, so later in the series we will also be checking about elliptic curve cryptography. How it will work with, we'll be combining this uh, elliptic curves with the finite series, right? So what we'll do is we'll combine these two stuffs and we'll create elliptic curve cryptography, ECG cryptography, sorry, it should be ECC again. Yeah, so that's what we're gonna do. Okay, so the main focus of this video is gonna be with elliptic curves, right? So like finite fields, elliptic curve can also look very intimidating, if you haven't seen them really before. But I really believe that you might have heard about these or studied about these in your class 11th and 12th and even your engineering time, right? And it's not really that tough. Most of you what you would need about elliptic curve would have been taught to you in algebra and something. But let's see, and let's try to figure out a lot of curves now. Okay. uh, so yeah, see, elliptic curves are basically like the equations that you might have seen in the pre-algebra kind of stuff, right? So they have y-axis on one side, their y-axis on one side and x-axis on the other side, and there is some sort of form that you can just create over there, right? So if you have to take a example for it, so elliptic curves can look like somewhat like this. Y square is something like x cube plus ax plus b. This can be a form for elliptic curves. So you might have worked with equations that would look similar to this, right? For example, uh, in your childhood time you might have studied about y equal to mx plus c. Mx plus c. So this is what we call as a linear equation. Linear equation or equation of a line, whereby m was your slope and c was your basically y intercept. Correct. And you could have also graph a linear equation for this. How would it look like? You would have this y, then you would have x, and you would simply create a line, and there would be some y called it y-intercept, and slope would be for this particular line. Okay, easy one. So similarly, you would have gone through some equations like quadratic equations. You might be familiar with them. We are just trying to do a very basic what do you call that, bx plus, let's just see. Okay, so how would or you would have also heard about cubic equation that would look like y equal to ax cube plus bx square plus cx plus d, right? We'll have the coding sessions later in the same series, but for now let's stick to the mathematical portion of it. Okay, so this is something like cubic equation. Okay, and you would have also learned about how you can keep these on graph. Like this would be your quadratic equation, and if you would go and talk about your cubic equation, how would it look like? I guess you could create this by yourself again, but something like this, it would be from 0 or whatever be the point, right? Origin point. Okay, so elliptic curve isn't all that difficult, right? So the only difference between elliptic curves and cubic curves is there is a term called y square on the left hand side. So this would simply look like this. Okay, and what effect would it be making is it would make the curve really symmetric over the x-axis. Let's try to draw one. It would, let's say, look like this, and it's symmetric over x. Crazy. This is very simple to understand. So this is what we call as a continuous elliptic curve. This is continuous elliptic curve. This is what we call as continuous elliptic curve. So the elliptic curve is also very less steep than cubic curves. Again, this is because of this phi square term in the left hand side, and many times, these curves can be what do you call those, disjoint, right? Let's say one face of it's looking like this and another face looking like this. This can be very symmetric as well as these are disjoint, and this is what we will call as a disjoint elliptic curve, right? Okay, cool. So if it helps, an elliptic curve can be thought of as taking a cubic equation graph, and then you're trying to flattening out the part of the x-axis, and then you're trying to mirror that part below the y-axis. Let me just show you how it would look like. Okay, so what I said was, you know so you can thought of it's a cubic curve, right? Cubic curve would go this way, right? And you're trying to flatten out the part above the x-axis. You are trying to flatten it out at the x-axis, and then you're trying to mirror it again on the x-axis, right? You're just trying to mirror it again on the x-axis, right? It's not working. Okay, this way. This is what I was trying to convey with it, and this is a very simple illustration for a cubic curve. Then there can be stretched cubic equations. You can have reflected over x-axis or something. But specifically, if you talk about bitcoins, if you talk about bitcoin, you would use an elliptic curve that is called SECP 256K1, and it uses a very particular equation. And the particular equations look like y square equal to x cube plus 7. Just see, it's all mathematics, right? And canonical form, you already might be knowing about canonical form. So canonical form is somewhat like y square. It's derived from x cube plus ax plus b, whereby a is 0. Sorry, it is where uh, a is 0 and b is equivalent to 7. This is what the equation would really look like, SECP 256K1. We will be using this equation later, in the coming videos, but this was just to make you get what actually it is. And if you were to what do you call that, draw it, if you were to draw it, how would it look like? Okay, let me just do it this particular way, and it's for the bitcoin basically, and it would simply look the same. It would intercept at -3, and it would intercept at 3, and from here it would intercept at -2, if you go more or less with more accuracy. Okay, in the coming videos we will be talking about how to code an elliptic curve in Python. It's something we'll be working on, and different points we'll be trying to plot. We'll do some point addition, and a lot more stuff. Let me clear this page, or let me just erase this whole page right now. Where's the page gone? Okay, here's the page. Okay, there is something called point addition. I wanted to throw some light on that. So elliptic curves are very useful because of something called point addition. Now, point addition is where we can do an operation on the two of the points on the curve and get a third point also on the curve. So this is called addition because the operation has a lot of intuitions we associate with the mathematical operations of addition. For example, point addition is cumulative. That is like, adding a point A to B is same as adding point B to A. What is this cumulation? If you are adding A to B, then adding B to A to B is also that similar. So the way we define point addition is like, it turns out that for every elliptic curve, a line will intersect either 1 point or 3 points, except for a couple of special cases. Okay, that's the whole point. Either the line will be intercepting the curve, if this is our curve, right, and it would intercept at either a single point, let's say, or if it would go, then it would 1 2 and 3, 1 2 and 3 points, right? Except for some very special cases, right? So the two exceptions can be, I'll draw the exceptions again on the same graph. Either the line is totally vertical, then only it can go with the 2 points, right? Or or it is a tangent to this particular curve. If I take a tangent to this particular curve, only these two conditions would be when we'll have some different cases, right? So we'll come back to these cases, and we can define point addition using the fact that lines intersect one or three times with the elliptic curves. No, 2 points define a line, so since that the line must intersect the curve at one more time, the third point reflected over the x-axis is the result of the point addition. Okay. Mm, and mass of point addition, you need to know identity, commutativity, associativity, invertibility. These are all things I guess you already knows about it. What is commutativity? A plus b this. If you talk about associativity, then that is a plus b plus c equivalent to a plus b plus c. This is all and when you talk about more into this is all about intuition. You can draw the curves and try to understand more about it, and take your intuition to the next level with the data backed stuff, right? Then in the later videos we will also talk about how to code this point addition thing. There we will understand these all stuff more in a better form. Okay. Point additions has a lot of, but what would it happen if you would be deriving the point addition formula? Can we do it? So there's something called Vieta's formula. I if you want me to go into more details, like how do we actually derive this point addition formula, I can have a video for it, a smaller video for that. you know uh, Viet-Forman's formula, we can also derive those things. We can derive the slope tangent to the curves. These are all very small exercises that you can do. So till now we have covered what elliptic curves are, how they work, and how to point addition. And next we will be combining these two concepts, that is field finite fields and elliptic curves, and make sure we get the elliptic curve cryptography. That's what the actual goal is. So yeah, this was all for this video, and I would hope to see you in the next video soon. Yeah, see you around. Stay healthy, guys.